Okay. Alright. Okay. Hello everyone. Welcome back to the live stream of the Odin project. A self-taught journey. I hope everyone is having a good day. Taught journey. So we're gonna get right back into what we were doing earlier. Okay, so we read the first introduction, and now we're on the motivation and mindset portion. Alright, so let's do this. Looks like we're doing pretty good there. Alright, so introduction. Oh, again, those of you that are just tuning in, this is a live stream, educational, learning experience, learn together, self-learning way to become a software, or actually a full-stack web developer. Remember, we're doing the Odin project, and if you want to go and check out the first stream, I would go do that, or come check out the website. Either or, it doesn't matter. You learn at your own pace. You do what you need to do to get things done, and I am doing what I need to get done by reading and learning. Okay, so anyway, introduction. Learning to code is incredibly rewarding, but can also be difficult and frustrating. Like any skill worth knowing, it takes time to acquire, and it can be learned in a weekend, or even a month. With that said, we believe anyone can learn how to program as long as they are willing to put in the time and effort. Oh, okay. Time and effort. So, before we get into the meat of the curriculum, we're going to cover the following to help you get the most out of the Odin project. The things that will help you succeed in your goal of learning code, and the pitfalls that you should try to avoid. Motivation. Take a moment to think about why you have decided to learn programming. Do you want to have a fulfilling career that pays well? Are you excited by the creative outlet programming provides? Are you determined to develop the skills and abilities to build any app you can think of? Do you want to start your own company by turning an app into reality? App idea into reality. And my answer to all of those is yes. I need a creative outlet, and I love being creative, either by playing music or drawing or whatever it may be, but I like being creative, and having an outlet is very good, especially for someone like me, which I will get into in a later video that I want to make. Do I want to have a fulfilling career that pays well? Yes, I do. Do I want to start my own company later down the line with an idea that I have? Yes. Can I say that idea now? No, not yet. Okay, your motivation could be a combination of these reasons or something else entirely. Whatever it is, hold on tightly to your motivation. This will be what pulls you through the end of this journey, giving you a definitive goal to aim towards. To give your motivation a bit of a boost, you can read about the success of others. A woman who taught herself enough to land a job in 5 months. A 32-year-old who taught himself programming using the Odin project over a year and landed a job. Oh my goodness. There's a monster over there. So let's go check this out. A little short thing. You can read that, huh? I made it. Job contract signed. And who wrote this? New country, new career. One girl's journey to become a web developer. I'm very excited to announce. Oh, this is New Code Girl Blogspot. So this is her blog. Nice. I'm very excited to announce I signed a job contract. Was able to go from a code nobody to signing a job contract for a full-on developer position in 5 months. No $30,000 dev bootcamp necessary, just still teaching with online tutorials and scoring a junior dev internship. Seriously, that's crazy, right? As of May 1st, my title will officially be software developer. I'm staying on. I am staying on at the company where I am doing my junior developer internship. If I make it, I don't see why anyone else out there can. If I can make it, I don't see why anyone else out there can. I started flirting with the idea of trying to become a web developer in November. I started reading some blogs from others that found jobs as junior devs after self-studying for 6 to 8 months and got motivated. There were 2 big obstacles to getting a job I saw when I started out learning to code. Living in another country and not speaking much of the native language. How am I supposed to find a job or internship then? No dev boot camps nearby. I almost considered doing an online boot camp. I didn't let these worries deter me. Here's my milestone on my journey to get a developer job. On November 13th, I successfully battled homebrew and Xcode error messages and installed Ruby and Rails and a text editor. On November 26th, I created a GitHub account. I didn't really understand the Git process at all. On December 16th, I finished my first Rails app, 1 month's Rails Pinterest clone. I kept working through every free online Rails tutorial I could find online. I started the pre-course work for 2 different online bootcamps, Tea Leaf and Firehose Project. I was considering doing one of these. On January 13th, I applied for a couple junior developer internships. I almost didn't. Some of them were posted in Dutch. I didn't think I qualified after only doing some online tutorials, Ruby and Rails for the past month, and I definitely didn't think I was qualified when I don't speak Dutch well. My husband convinced me to just apply, and the worst they could say is no or flat out ignore me, so I did. Caveat: there were no positions in my current city, so I applied in other cities within the commuting distance. I was willing to commute 3 hours round trip with Den Haag to Amsterdam every single day. I still commute. It's freaking tough, but I gotten used to it. If I get a decent seat on the train, I pull out the MacBook and work on code stuff for work, or work on Harley's Rails tutorial. On February 9th, I started a junior developer internship. Not struggling with tasks at work and reading Harley's Rails tutorial during my personal time. Okay, so after she learned a lot in 5 months, she got a job. That's cool. Let's see what this dude did. Oh, Reddit post. Okay. I'm 32 years old and I just started my first full-time job as a developer. 1 year ago, my programming knowledge was basically nil. Everything I learned I found via our learned programming, so I just wanted to share my experience. Just wanted to share my story here in case anyone was interested about me. I initially started programming for fun, but quickly realized that it was something I could see myself doing as a job as well, so I pursued it. I've worked in the film industry for the last 8 years and have been ready for this change for a while. I reached a point in my career where I felt I had plateaued, and to be honest, I felt a bit worried about my long-term financial stability. The industry has gone through some very painful changes lately, and most people I know are quite worried. Being self-employed was also starting to become a bit of a drag. How I started: I got all my how to get started information from our learned programming, or at the FAQ, and then tried out some of the different courses and show up on the subreddit. But basically, I don't want to go on too long with these other articles, but it's just saying that, you know, these people, they worked at it very hard, and they got where they wanted, and that's awesome. We just have to maintain that motivation and push just like that. Growth mindset. Your mindset is very important when teaching yourself any new skills, not just programming. Your mindset will have more of an impact on your choices or your chances of success than just about anything else. Excuse me. Someone with a fixed mindset believes that if they don't get something on their first attempt, they never will. They believe they simply aren't smart enough to be able to do or understand some things. However, there is a wide body of research showing that intelligence is not fixed, but can instead be developed. Someone with the growth mindset believes they can get better at anything with effort and persistence. What does that mean for you? It means you can learn new skills and develop new talents with persistence and grit. I totally agree. There will be many times throughout the Odin project that you will get stuck on a concept or a programming problem and may find yourself questioning your ability to learn programming. When you find yourself in this position, remind yourself that you may not get it yet, but that with persistence and grit, you will. Struggling with something is a growth. It doesn't matter how long you struggle with a concept or project. All that matters is you have the grit and tenacity to see it through. That's how real learning happens. While you're working through the curriculum, embrace the struggles you encounter with difficult concepts and complex projects. Be sure to celebrate your persistence at overcoming those struggles. When you find yourself questioning your abilities, reflect on the successes you have already achieved. While learning to program, the projects you have completed and the concepts you once didn't understand but now do. This is all the proof you need that you can do it. To learn more about the growth mindset, check out these resources. So here we go. It's a TED Talk. And so that's cool. We got some other like little resources here that we can go check out and yeah, we're not gonna worry about looking at that, but okay, cool. And then Khan Academy. And I think this is probably cool. Okay. I'm gonna have to read these. Alright, so the learning process. But yeah, I mean, I really believe that, you know, whatever you learn is just a small step. Just like I said in the earlier, or in the first part of this series, it's all a step-by-step process. You know, one step means that you're one step closer to completing your goal. So if you take no steps in a day, then you're no steps closer to where you need to be. Let's see. The learning process. Learning concepts and then practicing them will help you fully understand how things work and fit together. Projects are the ultimate method for ensuring that your theoretical understanding aligns with how the programming concepts and techniques actually operate. When learning, your mind will consistently switch between focus mode and diffuse mode. Focus mode occurs when you are consciously focusing on learning, reading, watching videos, or working on a project. Diffuse mode occurs subconsciously at times when you are not actively learning, such as when you're doing the dishes, exercising, or sleeping. In this state, your mind goes about the business of connecting what you have been learning to the things you know. This is where breakthroughs happen. It's important to know that your mind goes through these two states when learning, because you can utilize this to make your learning more efficient. When stuck on a concept or project, taking a break to refresh and let your subconscious work on making connections more often than not yields a solution to your problem. The trick is to put effort into solving the problem first and then take a break. In short, understand it, practice it, and finally teach it. So, you read, find an understanding, you put it to practice, and then you teach it, which is probably what I'm trying to do here with this type of experience I'm trying to bring. I'm sorry, I had a brain fart. Teaching what you know to others is a great way to solidify what you have. Sorry. Why are you yelling? Teaching what you know to others is a great way to solidify what you have learned and can often reveal holes in your knowledge that you wouldn't have identified otherwise. You can practice this method of learning by helping others in our community. To learn more about the best ways to learn, learning how to learn in Coursera is highly recommended. Okay, this is cool. Can you stop? Learning how to learn. Okay. The Ruby Rogues have a podcast on how to learn, which should be motivational and useful to you. So check it out for some useful thoughts on learning. Oh my goodness. So this is so I'm guessing this is a video? It is. It's a long one. So those are just excuse me. Learning things. Okay. What to do when you're stuck? You will inevitably get stuck at some point in the curriculum, perhaps due to a concept that you are having difficulty understanding, or perhaps due to something not working correctly in a project. Whatever it is, use the following tools to get unstuck. Google it. You can be certain someone else out there has encountered the same problem as you at some point. A quick Google search can often lead to the solution. Take a break. Allow your diffused learning state to work on the problem. Ask for help in our chat. Come prepared with your research. People will be more than willing to help you when they can see you have already put effort trying to figure out the solution on your own. Nobody wants to give you help when you've done nothing to help yourself. What is that? What is this? I don't know what that means. Okay, anyway, I'm messing with... Oh, heat advisory. Okay. Don't mind me. Just getting distracted. ADHD mind. Okay. Managing your study time. You have more success with Odin by putting consistent time into it rather than working on it once a week. Building a habit of studying every day at a specific time with a specific goal will ensure that you make consistent progress. It may take you longer than others to grasp concept, or it may take you less time. This doesn't mean you're smarter or dumber than others. It means you've had differing life experiences that may or may not have prepared you for learning this stuff. Someone who grew up around an engineer may have some advantages over someone who didn't, but it doesn't mean you can't learn those skills. The Odin Project isn't like college or university. It is self-paced and allows you to get a really solid grasp of concept before moving on. In school, you're forced to keep up or you will fail. The difference here is that coming into the Odin Project, you're not expected to have much knowledge. There are no prerequisites. We've had people be successful coming through here that only knew how to check their email with a computer. We've also seen success from computer science degree holders. Treating the Odin Project like a static timeline is understandable, but it is a sign of misplaced expectation. You simply don't know what you don't know yet, and that's okay. There's no due dates on things in the Odin Project, so you can spend the time to do it right and discuss the topics. Deadlines cause an unneeded stress. Since the Odin Project is a free and open platform, you are not beholden to a deadline. Creating your own deadlines is a good way to rush concepts that should not be rushed. This course is very research-based, meaning you will have to do research to complete tasks and projects. There's no telling if you can find the article or post that helps you in the right way quickly to meet your deadlines, but I bet you learned a ton along the way and that you can use in the future. People that do this kind of research and strive to write better solutions tend to become better developers in the future. There's no knowing how long it could take you to learn how to query stuff to find your answers. There are no solid guidelines on that. If you're doing the Odin project because you need a high-paying job right now, you're not going to become a solid developer within the time frame you have set. Stress and anxiety absolutely do not help you learn either. Relax and just enjoy the ride. Long story short, don't worry, just learn. Long story short, pitfalls to avoid. The following are some of the pitfalls that beginners often encounter when learning how to program. Try your best to avoid these. Procrastination will be your biggest enemy when trying to make progress. Solution: the Pomodoro technique, which I actually have written on my desk from when I was in coding bootcamp, is a way of managing your time in order to stay focused. The idea is to set a timer for 25 minutes and to work on the task until the timer goes off. If you get distracted or interrupted during the 25 minutes, start the 25 minutes of work over again. Once you successfully focus on work for 25 minutes, take a 5-minute break. When your break is over, repeat the 25 minutes of work and 5-minute break. After you completed the 25-minute blocks of work, take a longer 15 to 30-minute break. The Pomodoro technique is great for avoiding procrastination as it forces you to work without distractions. Since the work time only lasts 25 minutes before taking a break, it's not overwhelming, making it harder to rationalize procrastination. To learn more about the Pomodoro technique, read this great article. I would definitely recommend, the way I do it is, so you decide your task, you do your task for 25 minutes, you work on that task, and once the timer ends, you put a check mark on the piece of paper. And then if you have greater than 4 check marks, then you take the 15 to 30 minute break. But if you have less than 4 check marks, then you do the 3 to 5 minute break. It says 5 minutes. 5 minutes is probably the best way to do it. But you take that, and then once you get that 15 to 30 minute break, then you restart again from step 1, which is decide the task, set the timer, work on the task. Again, timer goes off, do a 5-minute break, go back, put the check mark, all that good stuff, and then it's pretty cool. Tomato timer, huh? Okay. Cool. I like that.
Mommy pet! Yes! Daddy pet! Yes! Sleepy!
You okay? But that's just, one technique. If you struggle with procrastination, it's definitely a good one to be able to do. Not taking breaks. As you get into the material, you may feel compelled to continuously study for long periods of time. It might seem like you're getting more work done at first, but this often leads to burnout, which consequently results in lower productivity. It may seem counterintuitive, but you will actually get more done if you regularly step back to recharge your brain and body. Studies show that performance increases after breaks of all durations, from extended vacations down to micro breaks of 30 seconds. John Trugalkos, Associate Professor of Management at the University of Toronto, says that mental concentration is similar to muscle. Our focus becomes fatigue after sustained use and needs a rest period to recover, just like a bodybuilder resting between sets at the gym. Solution: use the previously mentioned Pomodoro technique to time how often and how long to take your well-deserved breaks. Feel free to play around and experiment with different frequencies and durations of break. What to do during your break: listen to music, journal, doodle, meditate, play a quick game, go for a short walk outside. Here we go. And another article too about boosting your productivity. So, oh, I didn't want, no, please leave me alone. I don't want my free book. Thank you. Okay. But anyway, yeah, pretty cool. I will have to come back to all these links later. But I kind of got a grasp on about allotting time to studies. And I don't know if you noticed, well, those of you that are watching with me or tagging along later on, you know, we're going to be doing just pretty much just hour-long sessions just to be able to put information out, be able to read. And I want to do the hour sessions. I want to try to do them once a day, or it depends on, because I work, so after work probably just a session a day, because I don't get home till almost 5 o'clock. Oh, let me see here. No. Okay. Sorry, I'm having some technical issues. Sorry, stream status is poor. I'm just trying to keep it to where you guys can, like, mainly just to tag along. What's the whole point of this? It's just a tag along thing. Digital distractions. Digital distractions are email and Facebook notifications and time-wasting websites such as social media. These distractions break your focus and make procrastination tempting. Therefore, they should be avoided during study time. Solution: turn off notifications and add a blocker to your internet to limit your time on the distracting sites. Physical distractions are distractions from your environment, like a TV in the background or other people talking. These distractions can be as damaging to your focus as digital distractions. Solution: find a quiet place to study where you can go to focus in your home. If that's not an option, you can use the noise canceling headphones to block out noisy distractions in your environment. And that's what I do. I have a little child playing and screaming and everything, so yeah, that's always fun. But you know, I'm able to keep my mind just going. Rabbit holes. Because we cover so much material on the Odin project and link to so many high quality courses and tools, it is easy for students to get pulled into rabbit holes by spending time trying to learn all there is to know about a subject that they aren't ready for or won't benefit from much. We have put a lot of effort into structuring the curriculum so that all of the important things that you need to know about web development are covered exactly when you need to know them. Solution: stick to the path laid out as much as possible. Try limiting time spent going down rabbit holes, as these sidetracks can really ruin your momentum. Comparing yourself to others. Students often compare themselves to others who are farther along in their coding journey or have more experience. This is a recipe for depression and frustration. Solution: only compare yourself to your past self. Have your abilities and knowledge improved from where you were last week, last month, or last year. Be proud of the progress that you've made. Conclusion: learning any new skill is a journey full of speed bumps and obstacles to be overcome. We hope that the principles laid out here will put you in a much better position to succeed and to get the most out of the Odin project. Without further ado, let's jump into learning web development, and then some more reading. Monkey type, huh? Oh, okay, it's just to kind of see how fast you can type, huh? I haven't done one of these in a while. Let's see. Okay. So 90 words per minute, 98% accuracy, 75% consistency. So yeah, that's how fast I type right now currently. I mean, there's people that can type at like 100 something, you know what I mean? But it all comes with practice. That's cool. Okay, that's something to use. But yeah, if you have trouble with typing or anything, I would definitely practice before you. Well, as you progress is what I mean to say. I would definitely practice as you progress into growing into software development and. So don't be scared. You'll get faster as you go. I just type. I think that's decently fast. 90 words per minute. I've messed with computers almost my whole life, so I'm used to this. I'm not like, I don't know how to put it. I'm not trying to be. I can't even think of the word. But you get what I'm trying to say. I'm not like that. I'm just saying that you're gonna need that skill. It'll definitely help you. Okay. See, and there you go. I just got distracted. So cool. Ooh. Okay. Cool. Asking for help. Okay. Asking for help. Introduction. Along your programming journey, you'll inevitably need to ask questions in an online coding community like ours, or in conversations with your colleagues. While asking questions may seem rather simple, in a programming environment, it is essential to ask well-formed questions with as much context as needed so you can get the most out of asking for help. In essence, help others help you. This lesson will provide you with the tools to effectively ask questions in the community, such as our Discord chat, Stack Overflow, and in the workplace. This section contains a general overview of the topics you'll learn in this lesson, explains techniques for asking programming questions, explain and avoids qualities of bad questions, and ask effective and well-formed questions. Tips for getting the best help possible. Always provide your code and the surrounding context. You can ask theoretical vague questions, but you're going to get theoretical vague answers that probably won't be helpful to you and cause frustration on both ends, as you and the person helping you dance around the real issue. The only time code doesn't need to be provided is if you are asking a purely conceptual question outside of a specific project or code snippet. Additionally, provide as much context as necessary and zero in on the specific problems, such as pointing people to a specific function or line number in your code so people can give you their most relevant answers and quickly assist you. Sorry, my buddies are trying to distract me right now. Damn it. Okay, theoretical, yada yada, helping you dance from the issues, pointing. Is pointing people to a specific function or line number in your code so people can give you the most relevant answers and quickly assist you. Ask about the problem at hand, not the solution itself. A lot of learners ask exactly how to approach a given task or assignment in this curriculum, such as below. How do I complete step 5 of the rock, paper, scissors assignment? Keep in mind that you're actually supposed to figure out how to solve this assignment yourself, and figuring out an approach is essential to your learning journey. A much better question might look like this. Hey, I'm trying to return a string that displays the winner in rock, paper, scissors, but I'm getting a syntax error on line 12. How can I fix this? Here's my code. So in sharing your attempt, people know that you tried and won't suggest things that might not have worked for you. And won't suggest things that might not have worked out for you. It also allows them to debug your current iteration of code rather than sending you down a path that has you start all over again when you might be very close to a solution. Now, if you're completely stuck with where to start, it's completely fine to let people know that you're stuck. Asking where you can start and what you can research to get on the right track empowers you to be able to resolve issues largely on your own in the future. It might even empower you to help others with the same issues later on. It is also recommended that you share your pseudocode so people can nudge you in the right direction or correct any misunderstandings you may have. People take... Okay, well, let's see what does pseudocode mean? Pseudocode is an artificial and informal language that helps programmers develop algorithms. Pseudocode is a text-based detailed algorithmic design tool. The rules of pseudocode are reasonably straightforward. All statements showing dependency are to be indented. These include while, do, for, if, switch. Pseudocode is a step-by-step written outline of your code that you can gradually transcribe into programming language. Oh, okay. So it's pretty much like designing out your code. Like, okay, let's say I'm making a calculator, right? Well, I have this calculator that I want to input a number and add another number to it, and then it's going to give me an answer when I hit the submit button. And then, so therefore you just describe, okay, I have my input fields input, and then how do I display, you know, all that, like being able to write out what you're trying to do and then writing it out in code are two different things. But the pseudocode is pretty much writing out what your program is trying to do. That's cool. Okay. I mean, I'm sure I knew that somewhere deep down in my mind, but I was just double checking. Okay. Don't take asking for more context to heart. People who volunteer in coding communities are here to help, but a question you may feel is coherent and obvious probably isn't if you are being asked for more context. While something may seem obvious to a beginner, it's sometimes nowhere near obvious to an expert. An expert knows about many, many more situations that could cause an issue someone is experiencing, and would want to refrain from sending a learner down the wrong path. People take time out of their day to help, so make it as easy as possible for them to help you. There's probably a good reason why they need more information, so trust their judgment and experience when they ask. Many people who help in coding chats are unpaid volunteers and are in no way obligated to answer your query. But because they truly do want to help you, they will ask for more information when needed. So here's our first assignment. Read and bookmark this amazing article by Gordon Zhu. It is a great reference to refer to whenever you find yourself needing to ask for help, and you might find yourself solving your own problem as you think about the points listed in the article. The video linked in this article is no longer available, but that is not an issue since we explain debugging in detail later in the curriculum. 2. Read about the XY problem, which is a common pitfall both new and experienced programmers fall into when asking questions. 3. Check out this article from the world's most popular programming help resource, Stack Overflow. While asking for help is encouraged, it is important to avoid becoming a help vampire and be respectful of the communities of persons you are asking for help. This resource goes in depth to identify what a help vampire is, gives those who help others the tools to empower folks to ask questions effectively, and help the help vampire effectively. So let's go ahead and read what they're asking us to. How to be great at asking coding questions. Print this out and read it out now. Read it now. Then post it on your wall. Each time you have a question, read this again until it becomes second nature. So the situation. Most people are absolutely terrible at asking questions, but the good thing is that you can follow a few simple steps to be great at it. Whether you're part of the team on Stack Overflow or a student at Watch and Code, asking good questions is essential. People that ask good questions are more effective because they get better answers more quickly and more often. They are also taken more seriously and get more respect, which matters if you care about your career. Good questions save time, and bad questions waste time. Bad questions create unnecessary back and forth conversation, which create frustration and conflict. People that ask bad questions get frustrated because they can't help. And people that are trying to help get frustrated because answering bad questions is so damn frustrating. Bad question askers usually don't get far in their careers. That's because working with them is pure frustration. If you were a manager and had to fire someone, you'd immediately think of people that ask bad questions. The only thing that saves most bad question askers is that everyone around them is bad too, and so in relative terms, they look all right. I'm in a field where I have to ask questions all the time right now, as an apprentice electrician. I'm constantly asking questions about what things are, how they work, why they work, things like that. And it's always good to not, I know they say there's no such thing as dumb questions, but there are dumb questions. Use your common sense first before asking, and then if you cannot figure it out, or if it's something that common sense cannot help you out with, like, I guess like mathematical, more, how do I put it? Require more thinking or knowledge of the situation that you're in, then ask a question. And if your common sense meter just does not tick off for you and you just cannot understand what you're trying to grasp, then ask anyway. They may look at you like you're dumb, but as long as you get an understanding of what is going on, then that's better for you. So I totally get this. Ask good questions, especially when I worked in the jail. You don't ever want to ask stupid questions because you're gonna be looked at terribly. But to each field it's different. Everything's different. I can ask stupid questions now, and they could look at me stupid or they won't. It all depends. But don't even take that as discouragement if you ask a dumb question and they answer back with, "Are you stupid?" Because there's someone else that's going to answer your question. Okay, the person that's telling you that "Are you stupid?" is someone that you don't want to interact with, because they don't care about your question. So I'm sure you can find someone that can answer your question. The process. 1. Understand the code to the best of your ability. Yes, actually do this. Do not rush this step. Go through line by line and figure out what each line does. Take notes. Think about things that might be confusing. Let them sink in. Google unfamiliar concepts. You want to avoid asking a question that you can figure out on your own with a quick Google search. Use a debugger to help you. If you don't know how to use a debugger or don't know what it is, watch this video below. Okay, and then like I said on the Odin project, we're gonna go over that later, so no need to worry about that. 2. Clearly describe the problem. Explain the context. For example, if you're a student at Watch and Code, provide the URL for the associated lesson and explain what you're trying to do. If you have a question about a video, provide the timestamp so that someone trying to help you can reference the exact place where you got stuck. Explain the exact steps you took to produce a problem. For example, did you click 3 buttons in a specific order? Did it work fine in Chrome but not in Safari? Explain every little step. Explain what you expect to see. Explain what you actually see. For example, if there's an error message, share the entire error and the line of code that caused it. If there's a weird user interface problem, take a screenshot. Provide the code that illustrates the problem. If you are working on a large project, isolate just the part that is broken and share that. When you share code, make sure that the code doesn't change by the time someone looks at it. That means you should create a separate copy of your code just for your question. If you change the code by the time someone looks at it, your question is not just a bad question, it is inaccurate, which is worse than bad. That's because everything might have changed, but there's no way the person answering will know about it. Do not punish people that want to help you. Make sure the code you're sharing can reproduce the problem. Take the code you shared, make sure it behaves exactly like you described. If you share a broken code that doesn't replicate the problem, it will be impossible to help you. 5. Format your code consistently. It doesn't matter what style you use, just make sure that you're consistent. This makes your code easier to read. It also helps you with the next step. 6. Check yourself for typos. Nobody wants to look for your typos. If you can't find your own typos, you need to learn how. Just keep reading. For example, if you're stuck on a lesson in a tutorial, go back to a point where your code worked and redo the lesson from there, making sure that your code continues to work each step of the way. If you get to a point where your code doesn't work, redo the lesson and double check for typos. If you're on a specific lesson and the code is provided, check the provided code and see if it works. If the provided code works but yours doesn't, then you have a typo. Now that you are sure that you have a typo, it's your job to find it. Go back and methodically brain fire. I'm already at that 45-minute mark, so I'm almost to the hour, which means it's going to be an end for probably today, or maybe at least for now. We'll see. Where was I at? If you have a typo, make sure you go back methodically and figure out where you messed up. Do not waste someone else's time and ask them to do something that you should be doing yourself. I know I didn't say that, but you should do yourself, whatever. 7. Explain what you did to troubleshoot the problem. Come up with a list of hypotheses about what the problem might be, and then test them methodically. For each hypothesis, explain what you did to test each hypothesis. During this process, you might figure out the problem yourself. This is very common. Explain what you think the problem might be. Based on your tests in the previous step, provide your best guess on what you think the problem might be. 9. Proofread your question. Read through your question and make sure you provided everything that someone would need to hear to answer it. Edit for clarity. If you think something might be confusing, fix it. If there's a typo, fix it. If you have typos in your question, people will assume that you have typos in your code. And like I said before, other people are not your personal typo hunters. 10. Send updates. And remember, this will not be your last question. If you figured out the answer before anyone can respond, then tell people so. They don't waste their time looking for an answer you've already found. When you get an answer back, take time to digest it carefully and fully understand what the person is saying. Keep in mind they might not actually be right, so you need to verify that their solution works. Thank each person that helped you, and remember that they didn't have to answer your question, but for some reason they wanted to. So, pretty cool. Thank you, Gordon Zoo, for the awesome article. So yeah, just in other words, keep your questions clear, free of typos. Make sure that you explain processes that you've tried to do. And don't just post a question that you can Google, okay? Look it up. Take your time, research. If you're stuck on something, look it up first. I guarantee you're going to find an answer somewhere. I guarantee it. Google has the answer for everything. Yeah. So, the XY problem. What is it? Alright, what is it? The XY problem. The XY problem is asking about your attempted solution rather than your actual problem. This leads to enormous amounts of wasted time and energy, both on the part of people asking for help and on the part of those providing help. User wants to do X. User doesn't know how to do X, but thinks they can fumble their way to a solution if they could just manage to do Y. User doesn't know how to do Y either. User asks for help with Y. Others tried to help user with Y, but are confused because Y seems like a strange problem to want to solve. After much interaction and wasted time, it finally becomes clear that the user really wants help with X. and that y wasn't even a suitable solution for x. The problem occurs when people get stuck on what they believe is the solution and are unable to step back and explain the issue in full. What to do about it? Always include information about a broader picture along with any attempted solution. If someone asks for information, do provide details. If there are other solutions you've already ruled out, share why you've ruled them out. This gives more information about your requirements. Remember that if your diagnostic theories were accurate, you wouldn't be asking for help, right? So here's an example. Noob doesn't actually want the last three characters in a file name. He wants the file extensions So why ask for the last three characters? How can I echo the last three characters in a file name? If they're in a variable, echo, right? Why three characters? What do you really want? Do you want the extension? Yes. There's no guarantee that every file name will have a 3-letter extension, so blindly gambling 3 characters does not solve the problem. Example 2. If Angela just started by explaining she wants to prevent others from detecting her OS, this could have been much shorter and more productive discussion. Okay, so that line of code returns some lines starting with OS, how to change it. Look in the source code for nmap, find out how it figures out the Linux part, then rewrite your TCP IP stack to not operate in a way nmap can detect. Yeah, but I don't know about Linux System API at all. Well, nmap's fingerprints is based on the way the TCP IP stacks work. There are no real way except to rewrite the appropriate parts of said stack. I really need to avoid these messages. Can IP tables do this work? Well, don't use OS detection on version scanning. I want to prevent others from knowing the type of my OS. Okay. Well, I guess I got some more to learn about. That just seemed a little confusing, but I'm not there yet, so that's fine. But again, same thing. Focus on your questions. Don't make it harder than it has to be. How do I ask a good question? We'd love to help you. To improve your chances of getting an answer, here are some tips. Search and research. And keep track of what you find. Even if you don't find a useful answer elsewhere on the site, including links to related questions that can help others in understanding how your question is different from the rest. Write a title that summarizes the specific problem. The title is the first thing potential answerers see. And if your title isn't interesting, they won't read the rest, so make it count. Pretend you're talking to a busy colleague and have to sum up your entire question in one sentence. What details can you include that will help someone identify and solve your problem? Include any error messages, key APIs, or unusual circumstances that make your question different from similar questions already on the site. Excuse me. Spelling, grammar, and punctuation are important. Remember, this is the first part of your question others will see. You want to make a good impression. If you're not comfortable writing in English, ask a friend to proofread it for you. If you're having trouble summarizing the problem, write the title last. Sometimes writing the rest of the question first can make it easier to describe the problem. Examples: bad, C# math confusion. Okay, good. Why does using float instead of int give me different results when all of the inputs are integers? Bad, PHP session data. Good. How can I redirect users to different pages based on the session data in PHP? Bad, Android if else problems. Good. Why does string equal? So I think that's not strict, right? What is the operator for that? Okay, so this converts it to the same type. This is strict. Okay, gotcha. And you'll learn that later. I was just trying to remember. I didn't remember what exactly that does. Why does string equal value evaluate to false when string is set to value? Okay. Introduce the problem before you post any code. In the body of your question, start by expanding on the summary you put in the title. Explain how you encountered the problem you're trying to solve and any difficulties that have prevented you from solving it yourself. The first paragraph in your question is the second thing most readers will see, so make it as engaging and informative as possible. Help others reproduce the problem. Not all questions benefit from including code, but if your problem is with code you've written, you should include some. But don't just copy in your entire program. Not only is this likely to get you in trouble if you're posting your employees' code, it likely includes a lot of irrelevant details that readers will need to ignore when trying to reproduce the problem. Here are some guidelines. But I think that's gonna have to be it for right now. I actually gotta use the restroom, if you know what I mean. But thank you guys for tuning in with me. We'll continue on reading probably later, either later this evening or tomorrow. But yeah, we'll continue on part 3 of the assignment that we have, our first assignment in Foundations. Alright, thank you guys. I hope everyone has a great day, and I'll talk to you all later.